All right, here's the sixth video, Refraction of Light Labs, Part B, from water to air. We're going to look at the discussion questions and with our data in front of us, and we'll try to answer those. So question one, how is the light refracted when the angle of incidence was 0? You can see here, angle of incidence was 0, angle of refraction was 0, so light passed right through without changing direction. Number 2, when light travels from water into air at an angle of incidence greater than 0, how is it bent in relation to the normal? So you can see here, angle of incidence is 10, refraction is 14, 20, angle of refraction is 28, angle of incidence is 30, angle of refraction is 50. Look at all those values for the angle of refraction. You can see that they're greater. So light is actually bending away from the normal there. Question 3, what do you notice about the ratio? Sine I over sine R for all angles of incidence greater than 0. And what is the value of the ratio? All right, so what we will do is round each of these. So 0.71 becomes 0.72, 0.72 becomes 0.73, 0.653 becomes 0.65, and then 0.669 becomes 0.67. All right, so we got some difference there, and you know, that might have been just positioning the prism a little bit incorrectly, positioning the ray box just a little bit incorrectly, but we've got a bunch of values that are pretty close to one another, you know, around 0.7. Okay. Question 4, why is there no refraction at the curved surface for both labs? What we're trying to do is actually determine in a more simplified way how light is actually refracted. In a simplified way, so the flat surface is meant to be the boundary between water and air, no matter what the direction of light actually is. If you start dealing with curved surfaces, then you know the mathematics gets a little bit more difficult. Question 5, what do you notice about the refracted and reflected rays as the angle of incidence increases? So you can see as we're increasing the angle of incidence, we're increasing the angle of refraction quite dramatically here. So the difference between 10 and 14 is quite small. The difference between 40 and 74 is quite large. So we're actually increasing the refraction away from the normal. Question 6, above approximately 45 degrees, what happens to the light once it reaches the boundary between the water and the air? You can see here at 40 degrees angle of incidence, we get an angle of refraction at 74. But as soon as we jump to 50 degrees, we don't get light refracting anymore. We get light reflecting. So at 45 degrees and greater, refraction is actually not occurring anymore, and we get what's called total internal reflection. Question 7, at what angle of incidence is the angle of refraction 90 degrees? Determine the answer experimentally. Draw a diagram of the situation. Check your answer mathematically. We didn't really do that part, but somewhere between 40 and 50 degrees, when light was coming in at an angle, then light would have refracted out right along the surface of the prism. Okay, and we refer to that as the critical angle. And then question 8, what's the physics term for that angle in question? Well, again, it's the critical angle. Question 9, explain the criteria required for total internal reflection. Basically, the angles have to be greater than the critical angle, and then instead of getting refraction, you're getting light reflecting back into the substance. Okay, and we'll deal with that particular idea of total internal reflection and the critical angle in future labs. Okay.